The distributive property basically says that if I have a number A times a quantity B plus C, I can distribute or multiply over that number and get A times B plus A times C. For example, let's look at this expression 2 times 3 plus 4. We're going to look at it two ways. If I say I'm going to focus on the parentheses first and add those items, I'm going to get 2 times 3 plus 4 is 7, which ultimately gives me 2 times 7, which is 14. Or, if I use the distributive property, I can say, well, let me distribute over the 2 into the 3 and the 4, and I'm going to end up with 2 times 3 plus 2 times 4. That's going to give me a 6 plus 8, and we know 6 plus 8 ultimately gives me 14 again. So either way I do it, I get the same answer at the end. The distributive property basically says this guy outside multiplies over into both items that are added or subtracted from each other. So let's look at a few examples where we use the distributive property to simplify the given expression. Since we have to use the distributive property for these two pieces, parts A and B, I'm going to distribute the 5 into both the 6 and the 1. So I have 5 times 6 plus 5 times 1. That's going to give me 30 plus 5, and ultimately 35 as my final answer. Similarly, even if I have a negative, I can still distribute this over, and I'm going to end up with 5 times 6 minus 5 times 1. I just kept the minus in the middle as was, or you can say 5 times negative 1, which is negative 5. So 5 times 6 is 30, minus 5 times 1 is 5, 30 minus 5 is 25. What happens if I have variables involved? Well, let's distribute the 5 over into the x and the 1. So I have 5 times x basically plus 5 times 1. I can use parentheses here if I want to also. So 5 times x is just 5x, 5 times 1 is just 5, and then there's nothing more I can do. This one contains an x, this one doesn't, so that is my final answer. Let's say I do the same thing here, distribute over the 5 into both pieces, and we end up with 5 times x minus 5 times this one guy. That's going to give me 5x minus 5 times 1 is 5, and that's the most I can do for that one. What happens if the guy outside I'm distributing is a negative number? Well, not much different. Still, the negative 5 goes into both pieces and multiplies through, so I have negative 5 times x plus, this plus just carries over. First guy is negative 5, second guy inside the parentheses is 2. So that's going to give me negative 5x. Negative 5 times a positive 2 is a negative 10, and if I want, I can rewrite that as just simply a negative 5x minus 10. This one is okay, or if you stopped in this step, that's okay as well. Part F, let's distribute over the negative 5 into both pieces. So we've got negative 5 times x. I can do a plus minus here since I can go straight to negative 5 times negative 2 is a positive 10. We could do that if you want. Or if this negative sign is confusing you, we can do the change business. So let's look at it both ways. If I do the change business, then I've basically got negative 5 times the x plus negative 5 times that negative 2. So if I change the subtraction problem into an addition problem, I do my change business, then I have first guy times second guy plus first guy, or first guy times first guy, and then first guy times second guy. So that's going to give me negative 5x plus negative 5 times negative 2 is just positive 10. Or remember, if you don't do the change business and you want to jump right to the answer, you can say, well, I have a negative 5 times x, and then a negative 5 times a negative 2, which is a positive 10. Either way, you get the same answer. Let's look at a couple more. So part G, simplify using the distributive property. This guy looks a little bit different than parts, let's say, E and F, because the number outside the parentheses is not in the front but in the back. Well, it doesn't matter since multiplication is commutative. We basically have this first chunk times 3, so we can go ahead and make the 3 distribute into both pieces from the back, or if you don't like putting the 3 at the end and you're used to the 3 being in front of the parentheses, you can say, well, I'm going to use the commutative property and switch their order. Since it's the first guy times the second guy, I'm going to switch the order and say second guy times the first guy. And thereafter, you can do the same thing we've been doing so far. 3 times a is 3a, and let's do this piece quickly in our head. 3 plus 4 is, or 3 times 4 is 12. Same thing here. If we don't like the 7 coming after the parentheses, we can say let's put the 7 in the front. Order of multiplication doesn't matter. First chunk times second chunk, I'm going to rewrite it as the 7 times that chunk. So now we've got distribute 7x plus 7y. Since this contains an x, that contains a y, I can't combine them any further. That's the most I can do. Alright, let's look at part I. I have a negative 2 outside, distributed through into both pieces. That's going to give me a negative 2 times 4x plus a negative 2 times 3. Well, here I have negative 2 times 4x, and remember there's really a multiplication sign between the 4 and the x. So since I can associate when I'm multiplying three things however I want to, I'm going to focus on the negative 2 and the 4 and multiply those guys first. And that's going to give me a negative 8 times the x. Negative 2 times 3 is a negative 6, so ultimately I can write that as negative x minus 6 if I want to. This is okay, or if you stop there, that's okay also. So all we did was negative 2 times 4, which is negative 8, attach the x, negative 2 times 3, which is negative 6. When there's only a negative involved in the front, just like there was a negative 2 here, if you only have a negative sign, there's an invisible one there as well automatically. So I really have a negative 1 outside. And whenever you distribute a negative 1, all it does is switch the signs of whatever was inside. So a positive 4x becomes a negative 4x because you're doing negative 1 times positive 4. And a negative 3 automatically becomes a positive 3 because you're doing negative 1 times negative 3. So just simply a negative outside switches over all the signs of the stuff that was inside. Let's look at a couple more that look a little bit different than the ones we did before. They involve a little bit more work because I have sort of 3 items maybe that are going to ultimately be dealt with. So first thing I do is take care of the parentheses if I'm doing order of operations, but I can't combine the a and the 5 because they don't both contain an a, they're not like terms. But I do see this negative waiting outside of the parentheses. So I focus there, kind of like I did this problem here. I focus there and I think, well, there's a negative 1 outside. That's going to go over and switch all the signs inside. That's going to give me a negative a and a positive 5, only focusing on this piece. Then the 12 is waiting around, so I'm just going to bring that guy down. Now it looks like I can simplify a little bit more because I do have like terms. This negative 12 and this positive 5 I can combine. So that's going to give me 12 and 5, 17, and then plop down the minus a write down, and these guys don't both contain an A, they're not like terms. That's all I can do. So I distribute it first, and then I combine things that I could actually combine. Let's go to part B. Again, 3y and 5, not like terms. I can't squish this and combine them. So I focus what's outside the parentheses. Outside the parentheses, you have, it looks like, a -2 waiting around. So distributing the -2 might be a little bit confusing. Should I leave that negative with it? Should I just distribute the 2? If that's kind of throwing you off, you can do the change business and then say, I'm going to just distribute the -2. So we can say -2 times 3 is -6. Attach the y. -2 times -5 is a +10. Again, even if you do the chain here, you're going to get -2 and -5, which is still a +10. So all I did was distribute the -2 into both pieces. Now plop down the 4x that was in front of it, but I can't combine this guy, any of these guys, because this one contains an x, this one contains a y, this one doesn't contain any variables, they're not like terms, so that's the most I can do. -2 times 3, -6y, -2 times -5, a +10. This one says use, let's work sort of backwards, use the distributive property to insert parentheses in the expression, then simplify. So what we could do here is just say, right off the bat, I have sort of like, you can think of it as 6 apples plus 5 apples is going to give me, they're like terms, 11 apples. We could do that quickly without doing the distributive property. But what the directions really want us to do is think of this as, okay, I have an x outside and I must have a 6 plus 5 inside the parentheses for me to kind of work backwards and say, if I distribute the x, I have 6x. If I distribute the x, I have 5x. And so then therefore 6x and 5x must be 11x, because if I looked at it this way, these guys are like terms, and I end up with 11 times an x, which is 11x. So the directions sort of force us to think, okay, the x must have been outside, maybe in the front or in the back, and I must have had a 6 plus 5 that give me 11, so ultimately I get 11x. That's kind of what they're forcing us to do, but we know that 6 of these guys plus 5 of those guys automatically equals 11 of those guys. One more, 2b plus 8b. We already know that I have something like 2, I don't know, boys plus 8 boys equals 10 boys, because they're like terms, they both have b's, so I just add the numbers in front, which are called the coefficients. Or this business right here tells us insert your own parentheses. Well, since both of them contain b's, I must have had a b distribute into both pieces, the 2 and the 8, so that when I distribute it, I can have 2b for the first piece and 8b for the second piece. But I do know that 2 and 8 are 10, and I have b times 10, which is 10b. So this must have happened in the background for me to get 10b, but ultimately I do know that 2b and 8b give me a total of 10b.